Okay, compositions and inverses are related. Compositions was our topic previously. So the relationship is if you were to compose two inverse functions, you will find that they are inverses if and only if f of g of x gives you x and g of f of x also gives you x. So if you compose them either way, you have to get the same result, and not just any result, but has to come out to be x. So we're going to test that out here. We're given a couple of functions called f and g, and we're going to see if they're inverses by composing them. So I'm going to start with f of g of x. I'm going to do some color coding here too. Okay, so in order to tell whether or not these are inverses, I have to start with the inside function, and I'm going to need to replace it with what g of x is equal to. I do not have a numeric value to put in for x, so I'm just going to put in all of the function expression there for g of x. Okay, once I've done that, then I'm going to put 5x minus 2 in place of the x in f. So this would say 2 blank plus 5. That's my f of x. And then I'm putting g of x in the blank there. So 5x minus 2. And now I'm going to actually put them together. So I'm going to be doing the work to get them together. I think I want to do a very different color for that. So let's do a light blue. There we go. Okay, so I'm going to distribute the 2. So that would give me 10x minus 4 plus 5. And then when I combine like terms, I get 10x plus 1. Now, if these two were inverses of each other, when I did this composition, I would have to get just an x as the answer here. Now, since this is not x, then that means that these are not inverses. It looks like it says net. There we go, not inverses. Because I found that they were not inverses with the first composition, I don't have to try this second composition. I can already determine that these two are not inverse functions. So now I'm going to try it with these two. My f of x this time is in a quadratic with a limited domain, and my g of x is a square root function. So I'm going to start again with f of g of x, and again I'm going to do some color coding here. So I'll do g of x in pink. Okay, my g of x is my inside function, so the first thing I would need to do is replace g of x with what g of x is equal to. And now I can bring in f of x into the function here. I don't really need to worry about this part too terribly much. We'll talk about that in just a little bit if we find out that algebraically these two turn out to be inverses of one another. So this would say x squared minus 5. In place of the x, I just put a blank. And my g of x function, that pink one, goes in the blank. And then I need to simplify. So I'm actually putting together the composition now. So the first thing I would need to do is square this thing in parentheses. So when I square that, of course, I have to FOIL. So that would give me square root of x times square root of x, which is x. And then my outside would be 5 times square root of x, and my inside would also be 5 times square root of x. So add those together, I would get 10 square root of x, and then 5 times 5 is 25. And then I still have that minus 5 hanging out on the end there. So now I've got x plus 10 square root of x plus 20. Once again, this did not turn out to be just an x. So therefore, these two are also not inverse functions. And once again, I don't have to try the other composition, the g of f of x, because I was able to determine with the first composition that it did not meet that criteria. So they are not inverses of one another. So we'll try a third one. color coding once again. So I'm going to start with f of g of x. So this would be f of, and then I'll put g of x in pink again. And so the first thing I would want to do is replace g of x with what g of x is equal to. So on this one, that's the cube root of x plus 2. Okay, and now I'm ready to bring the x function into this. So this would be, it says x cubed, so I'm going to do a blank cubed minus 2. And then what I'll put it in the blank is my g of x function, which was the cube root of x plus 2. And now I'm ready to actually put them together, so I'll change colors here. So the cube root cubed, well, those two things cancel each other out. So that would give me just x plus 2. And then I still have the minus 2 on the end there. And x plus 2 minus 2 is just x. So far, I did get that f of g of x is equal to x. So that means this time around, I do need to try the other way. So I need to compose them the other direction. So I'm going to start with g of f of x, and I'm going to keep the colors the same there. And I'm going the opposite direction. So this time my f is my inside function. So the first thing I would do is replace that f of x with the function expression there, so x cubed minus 2. And now I need to bring the g function in there. So my g says a cube root, and then it says x plus 2. But in place of the x, of course, I'm going to put a blank so I can fill it in with the what I'm supposed to replace the x with from my previous step there. So that would be x cubed minus 2. Okay, now I'm ready to actually start composing them. So I'm changing colors here. So now what I would need to do first on this one is this stuff that's on the inside of the radical, because everything that's there is inside the radical. So I have to simplify that first. So inside there I've got x cubed minus 2 plus 2. The parentheses that are around the x cubed minus 2 really aren't doing anything because they're not preceded with a number that has to be distributed, and the number that's after it is just being added. So I can just pretend like they're not there. That minus 2 and the plus 2 cancel each other out, so I just end up with x cubed, sorry, the cube root of x cubed. Now, cube root and cube are inverse operations, so they do cancel each other out, leaving me with just x. So now when I composed them, the two functions the other way, g of f of x, I also got x. So that means these two are in fact inverses of one another. If I wanted to be really, really mathy in stating that, then I would say, well, that means that g of x is equal to f inverse of x. That's supposed to say f inverse. And I could also say that f of x, of course my pen would start lagging here because I'm almost done. There we go. So I would say f of x is equal to g inverse of x. Oh my goodness. I'm going to fix both of those because this notation is kind of important. There we go. All right, so this would be a really mathy way to say, yes, these two things are inverses. But of course, you could just answer yes on that one. Okay, now you answer the next question on the Google form. Make sure you're using composition so you can get the practice in with those.